Howdy and good day. We are starting off Unit 2 in Algebra with PO9, because is there any better way to start with a power objective? I think not. And this particular objective is on writing and solving equations in real context, specifically two-step equations. And they are called two-step equations because it takes 2 steps to solve them. So who would like to share with us how you would go about solving for the variable in negative 8n plus 11 equals negative 21? Negative 8n plus 11 equals negative 21. Carolyn? I want to ask a lot of questions, okay? So just be prepared for that here. This first one will probably take like 7 minutes to do, and the rest will be a lot faster. But you're absolutely right. We're going to subtract 11 from both sides. Why subtract 11? Well, it's already evened out because that equal sign means that the equation's balanced, right? So that's why we would subtract 11 from both sides, which is another question I'll ask in a little bit. But why subtract 11 initially? Kate? What does subtracting 11 do? How does that kind of get us to that goal of isolating the variable? Gabe?
Because then 8n is all by itself, and you can just take 8 away from it. And
negative 8n is by itself because 11 minus 11 is 0, right? A phrase that you hear me use often is opposite operations. And that's what we want to be looking for when we're solving an equation such as this, right? In the original equation, we're multiplying n by negative 8, and then we're adding 11. So to undo that, do the opposite of the operations in the equation, we're going to start by subtracting 11. That cancels that constant out, and we're left with negative 8n equals negative 32. My next question was going to be, why do we do it to both sides? And as Griff kind of alluded to, this equation, the last class talked about railroad tracks, right? Yeah. That equal sign is the center of the equation, not positionally, right? Because it's way over on the right side here. But if you were to think of this as like a balance scale in science class, that equal sign would be that center post, right? Everything on either side of that equal sign balances out. And so if we take 11 away from one side and not the other, what happens to our balance scale? It would not be balanced anymore, which would be a problem. Okay. Griff, you had your hand up.
I was going to say divide by 8 next.
Yes, but we're not going to be dividing by 8, actually. We're going to be dividing by negative 8. And that is because dividing is the opposite of multiplying. So we are going back to perm dots here, right? Those operations that are kind of grouped together, okay, they're opposite operations, and we see that here. So negative 8 divided by negative 8, what does that give us? Negative 8 divided by negative 8. It doesn't give us 0. It gives us 1, right? Which is what we want. We want to know the value of 1n. It's not enough to know that negative 8n's equals negative 32. We want to know what 1n is. So dividing by negative 8 does not give us 0 n's. It doesn't cancel out in that way. It cancels out in the sense that it's 1. And 1n is going to be equal to positive 4, because negative 32 divided by negative 8 is positive 4. Okay? So the original equation had addition and multiplication. So to undo that, to solve it, we did subtraction and division, the opposite. Yeah. You do need to show that you've checked your work. Now, whoa, calm down. Whoa. I understand that last year's process is a little bit more than I'm going to ask you to do. What I'm looking for is I want to see that you've plugged that value back into the equation. Negative 32 plus 11 equals negative 21. That's what I'd like to see. Yeah, that's what last class said too. I don't know what else. I mean, well, you are solving the whole thing.
No, she made us solve the whole thing. She made it check us over it. Check it over.
Don't make us do that though.
I don't know what you're talking about. So yeah, that's fine by me. Okay. One other question that I have for you regarding this particular equation here is, so we subtracted 11 first and then divided by -8. Could we have divided by -8 first and then subtracted 11? Does it matter where we start here? It does. It does matter. Okay. The reason why we started with that subtracting 11 is because remember what we're doing here, right? We're undoing the equation. We are working through it backwards to get n by itself. So we are undoing the order of operations. Because you would add as your final step for evaluating the equation to solve for it, that's going to be your first step to undo it. So we're working through perm-dodge backwards. Raise your hand if you've ever changed a tire before on a car. Nobody. Ooh, okay. Well, when you change a tire, what do? You take off the bolts, you take off the tire, and then you put the new tire on and put the bolts back on, right? You assemble it in reverse order that you took it apart. Okay? That's what's going on here, right? We are working through it backwards to get kind of where we started from, where we want to know which is the value for n. So perm-dodge backwards. You start with that addition or subtraction. Do the next one on your own. I'm going to pause the video briefly just so maybe we can chat more freely, and we'll get back on soon. All right, we are back. 3n plus 17 equals 77. Raise your hand and tell us our first step here. Olivia.
You do minus 17.
We would subtract 17, that being the opposite of adding 17. And what that does is positive 17 minus 17 gives us 0. They cancel out. So we have 3 times n equals 60. And as much fun as it is to know that 3 n's make 60, we want to know what 1 n is. So instead of multiplying n by 3, we're going to do the opposite of that. Divide 3n by 3.
Can we just put a line under the 3?
Yes, if you want to write it in fraction form like that, that's fine. Yep. And 3n divided by 3 gives us that 1n, which equals 20. Okay. Are you still looking?
No.
Why don't you pick up your... Okay. And so to check this then, 3 times 20 plus 17, does that equal 77? Well, 3 times 20 is 60. Plus 17, that is 77. Life is good. Next one. N divided by 5 minus 6.5 equals negative 4.5. This time, since we're subtracting 6.5, we're going to start by doing the opposite of that, which is adding 4.5. So we have n divided by 5, or sorry, I wrote 4.5. I meant 6.5. We have n divided by 5 equals positive 2. If you have negative 11 there, if you wrote n divided by 5 equals negative 11, you went the wrong direction when adding 6.5. You're starting at negative 4.5 and you're going to the right. You're going to surpass 0 and end at positive 2. Yes, Luke.
It's so weird having to switch from addition to subtraction. Whenever I'm not used to having to switch from addition to subtraction every problem because there's you have to subtract it with opposite signs.
Yeah.
So
you're used to.
Why would they do that? Why would they create math say you have to add it to this for it to work?
Well, because you have to think about and remember what we're doing, right? If we want to figure out what n is, we have to undo what we did to n in the equation to work back there, right? What we're saying is that I think this 3n plus 17 is a really good example for that. Whatever n is, we're multiplying it by 3 and then adding 17 to that to get 77, which means that before we added 17, what was the value of 3n? 60, right? And then before we multiplied n by 3 to get to 60, what was the value of n? 20. And so we worked our way backwards.
Okay.
So in this case, we are saying we're subtracting 6.5 to get to negative 4.5. So before we did that, what did n divided by 5 equal? 2. And then before we divided n by 5 to get to 2, what did n equal? And we can calculate that by undoing what we did. If we divided n by 5 to get to 2, then multiplying by 5, we'll get n by itself, and we'll get what we started with, 10. Does that make sense? Luke, are we good? Okay. So then to check this, 10 divided by 5 is 2, minus 6.5 equals negative 4.5. The last one, very similar to this, we're going to start with that addition or subtraction. We're subtracting 4 in the original equation, so we're going to be adding 4 to get n divided by negative 6 equals negative 11. If you got negative 19, you went the wrong direction. Okay. Hopefully you caught yourself when you checked your answer, right? If you began to solve it wrong, but negative 15 plus 4 is negative 11. Now we're going to multiply by negative 6. And we get positive 66 as a value for n. You show me that answer, I say, prove it, defend it. You say, well, 66 divided by negative 6 is negative 11, and negative 11 minus 4 is negative 15. I can't argue with that. All right? I could argue, but I'd be wrong, so. It is what it is. I suppose so. All right. Any questions on that? Okay. One part of the pretest that did not go so well was the naming or identifying the parts of an equation. The variable, the constant, and the coefficient. So with the word problems where your task is to write the equation yourself, you have to know what the pieces are. You know, what does this value represent? Where does it go? How does it affect the overall value? So we've got the variable, the coefficient, and the constant. The variable is that unknown value. An unknown value that can change depending on what we're trying to find out. Usually it's the letter, okay? It could be a symbol also, but for our purposes, we'll represent it with N, X or Y, or D, or C, or G, or whatever you want, okay? But it's the unknown value that can change. The coefficient, what is the coefficient? Sebastian? The number before the variable it represents a rate. It represents a rate. How much per whatever the variable is. As you'll see in the homework that we'll do, it's how much per month, how much per day, how much per foot, how much per card, you know, it's a rate of something. And it's being multiplied. The coefficients and the variable are connected. They're being multiplied together. That's why you'll see them kind of back to back. You know, in the above examples there, when we had negative 8n, n is the variable, negative 8 is the coefficient. Okay? A constant is a number that is by itself, much like Mr. Schultz on a weekend in high school.
Not anymore.
That's kind of sad.
Not anymore.
Well, I'm not in high school anymore.
Wait, I don't know.
Okay. A number by itself. All right. The reason why it's called the constant is that its value remains the same. It is not affected by the variable. Okay. It's the number by itself. Its value doesn't change. It's not affected by the variable. An example of that, you sign up to help a charity with preserving the rainforest. They ask for $20 up front, and then you'll give $2 per month after that. What equation can we write that's going to represent a $2 per month donation after an initial cost, a sign-up fee, if you will, of $20? Noah.
20 plus 2n.
Okay, I'm going to, 20 plus 2n is correct. More commonly, you will see the coefficient variable come first. Okay, so I'm just going to rewrite this, and since we're talking about months, I'm going to replace n with m, just to kind of make it easier to follow. But yeah, 2m plus 20, right? That 2, our coefficient, represents the rate at which we donate, $2 per month. Okay, our month is the variable because that's what we want to figure out. That's what we're testing, right? How much will we give after 6 months, after 8 months, after 2 years, right? That's what's changing. The $20 is the constant because that value doesn't change whether you're a member or you're contributing for 1 month or 10 years, right? You pay that when you start, so that value is always there. It's a constant. Griff.
Would you only have to pay the 20 the first time or like every time? Right.
Yep. Up front is kind of like just a one-time thing. Oftentimes when you sign up for a new phone plan or cable plan or something, there's always like an upfront cost. A down payment on a car would kind of be that one-time thing.
To find 6 months, you would just do 2 times 6.
Exactly. 2 times 6, but then plus 20 because that was part of what you contributed. So for 6 months, your equation would be 2 times 6 plus 20. $2 per month for 6 months plus the 20. That's a total of $32. Okay. For 8 months, what changes? You change the 6 to the 8. 2 times 8 plus 20. Now you've $36. Notice the 20 didn't change because that was still the initial just sign-up cost. Okay. Hold on. Let's let someone else jump in. For 2 years now, what do we have to do for that, Linnea?
2 years is 24 months.
Good. We do have to convert from years to months because that's the unit our variable represents. That's why I used m there, right? Because we are talking about a certain months. So 2 times 24 plus 20. After 2 years, you've donated $68. Yep. Okay. Mr. Schultz has 3,039,001 hairs on his head, and each day he loses 60 of them. How sad. Write the equation. How many hairs will he have left after 120 days, 1,580 days, 50,650 days? Who's got an equation for us that would make sense for this situation? Luke.
So you have to do 60. You'd have to do 1 times 60, and then you probably divide that by 3,390. Yeah. You have to divide by the amount of hairs on your head.
There's not going to be division here, okay? Because remember I said that coefficient is going to be a rate. Kind of the key words that identify a rate are per or each or every, right? It says we are losing 60 hairs, not me, losing 60 hairs each day. That word each kind of represents that we're multiplying.
How many?
Well, that's what we have to solve for, right? Colin?
So you want the equation, right?
I would.
Alright. So 60 times 120.
Well, let's leave it as a variable for now before we start plugging things in. So rather than 120, let's just put D for days.
And then after that you do minus 3 million.
Okay.
Would you put the 3 million before then? Yeah.
I was just about to say, how do we feel about this? Because if we just think about this, Colin, you want to amend?
Yeah, like put the big number on the other side.
Okay, so it did, yeah. 3,039,001. Okay, and then you said 60 times the number of days. What operations go in between there? Subtraction, right? We are decreasing that initial amount by 60 hairs per day. This is our constant because that's where we're starting, boys. This is our constant because that's what we're starting with. And then we're losing 60 hairs per day. So whatever that total is, minus 60 per day. So then when we plug in 120 here, oh, you're fine. 3,039,001 minus 60 times 120. That's 60 times 120. The reason why, the order of operations, we're doing that first, because that represents how many hairs we're losing. And by we, I mean me. And we're subtracting that from the total. So how many hairs are left after 120 days? Linnea?
3,031,881.
Do we have a second on that?
Let me check.
Let me check. Yes, that's
Okay.
Wait, hold on.
Okay. 801? 801? Okay. Maybe check your calculation there. Then the next one. Yeah, Max.
So would we use the new number and subtract that from 60 times 1,580?
Right. So the next question now is, how many hairs will I have left after 1,580 days? So the only thing that changes, I'm still starting with my 3,039,001 hairs, but now I'm losing 60 per day for 1,580 days. So the only thing that changes is that variable, right? Which does affect that product with negative 60, but my initial starting point didn't change. That's why it's a constant. I'm always starting with that 3 million number. And how many hairs do I have left after 1,580 days? Camden?
2,944,201.
Do you have a second on that?
No, that's right.
Wait, hold on.
We're good? Okay. And then lastly, 3,039,001 hairs minus 60 per day for 50,650 days. I didn't leave a lot of room to write because how many hairs will I have left?
One.
I hope it's really long so I can curl it and comb over back and forth and everything. But yeah, one hair. Okay. So what I want you to recognize here, the role of that coefficient, that rate, right? Some amount per something. Okay. The constant, that value that never changes, and then the variable, that's what we're plugging things in for. Okay. Any questions on this?
Nope.
So Noah.
Why was I raising my hand?
I don't know. Did you have a question?
Probably did, honestly.
Well, if you think of it later, you can put it in the Google question form.
Probably can.
There you go. Okay. So the second page of this, and this homework is not due until Monday because tomorrow is the retake day, so we're not going to check in homeworks. This is due Monday, but I would like you to do these 8, showing your work, showing you've checked your answer. They are very, very similar to the 4 on the first page that we did together. And then the 2 word problems down below here. Shh, folks, hold on. This is where you get to practice that setting up the equation yourself. So it says you are just starting to collect baseball cards and already have 30 you've got from your parents. What does that 30 represent? Is it the coefficient, variable, or the constant? Linnea. It's the constant. Why? Because that's what you already have. Okay? That's what you're kind of starting with. You go to a trading store with 3 of your friends with the agreement that however many cards the group gets, you will divide them evenly among the 4 of you. There's a big word in that statement that gives you a hint as to what operation we're going to be using here. Okay? You will divide the cards you get among the 4 of you. Shh, nope. How many cards will be in your collection if the group gets 40 cards, 96 cards, or 224 cards? Okay, we're not going to take answers now. We'll talk about it Monday. If you have questions on it, I will take those. Luke? Okay. All right. Then the second one, as a scuba diver descends into deeper water, the pressure of the water on the diver's body steadily increases. The pressure at the surface of the water is 2,117 pounds per square foot. The pressure increases at a rate of 64 pounds per square foot for each foot the diver descends. What will the pressure of the water be when the diver has descended 10 feet, 25 feet, 150 feet? Olivia? Yeah. So the entire second page is your homework, but it is not due until Monday because tomorrow is your retake day. Please don't forget about your Khan Academy tonight. Algebra, geometry, both classes have something due. The football picks are due tonight as well if you want to still participate in that. And I think that's it. Any other questions?
Don't forget to shoot.
That's all you math.
Don't forget.